Thanks, John. I'm going to keep this one real quick. Let's get a little deeper and look into the developments in developer tooling that we've seen in the Charmed ecosystem. Pietro Pasotti, take it away.
Thank you, David, for the introduction, and hello, everyone. I am Pietro Pasotti, and I'm here to talk to you today about charming dev tools. I work in Canonical since January in a team called Operator Framework, or CharmTech. And a few words about who we are, what we do. Our main task is developing and maintaining the Operator Framework, which is a library called Ops, Python library that people use to write charms with. And aside from that, we generally work with Juju, Pebble, Charmcraft, and let's say all the machinery that is surrounding Juju core and enables people to write charms in general or just better. We also maintain a bunch of charm libraries, such as Operator, Libs, Linux, Rolling Ops, Harness extensions, so testing facilities, and so on. And we provide support to charming teams, internal and external. So we are kind of the reference point when it comes to best practices around charming and patterns to make the charming ecosystem better. Last but not least, and that is the presentation, the topic of the presentation today, we develop charming tools. So tools, command line tools typically, that aid the charmer when it comes to debugging and developing their charms. When I joined Canonical, I realized that there was a gap between the say native Juju tools, so the command line interface offered by the Juju client, and what the charmer needs when it comes to debugging, introspecting, hacking around the charm, and especially in a runtime environment, and help in general in manually testing, manually interacting with charms and local models, especially when you're developing a charm. And for that reason, I started working at some point on a project called Jhack, short for Juju Hacks. Now, what is Jhack? So it started as a personal project, playground to explore charm dev tooling. So it was not born an official Canonical tool. It's something that I just played for fun and just for my own development. So I started just wrapping around commands that I often used or things that I thought were useful. And then at some point I started opening it up and giving it out to people to play with, and people liked it. So here I am. Now the core thing that you need to keep in mind is that eventually we're going to phase out Jhack. So Jhack eventually, hopefully, the good things in it will move into Juju core or Python lib Juju, and the rest will be discarded. So it's really like a staging playground. And the best outcome for it that I can see is that Jhack at some point becomes redundant. But until we have to, let's play with it. Now, a few words about the charming development flow, which is going to explain to you where does Jhack fit in the picture. Every charming activity, let's say, starts with either you have an idea of something you want to add or a feature you want to develop, or there is a problem. When you're adding something, you typically write some code and some unit tests. You write some unit tests, whatever order you prefer. And as soon as you're satisfied that the charm has a good chance of actually working, you're going to deploy the charm on a local testing cloud, such as Microcates or LexD Cloud. And you're going to play around with it. You're going to verify that things look as you think that they should, that the user interface is friendly, and so on. And once you're happy, you write some integration tests. The reason you do that last is because integration tests take a long time to run. And it's not something you want to iterate with. When there is an issue, there's a bug, you also typically start by trying to reproduce the bug locally. And that means deploying the charm on a local testing cloud, playing around with it, SSHing into the unit, look at the state. And then once you have found the bug and fixed it, hopefully. You're going to write some tests to catch regressions and then release again. Now, the persona that I want to talk about today is Hackerman. It's a fictive character, of course, but it's the developer that is playing around with local development cloud. So please do not do the things that I'm about to show you in a production environment. Yeah, so this is the character that I have in mind. So yeah, maybe good to mention that the things that I'm about to show are meant for an audience, for people who already know a bit about Juju development and charming. Somewhat, somewhat already experienced. I'm going to assume a lot of knowledge, and this talk might be fast for those of you who are new to charming. So in that case, please come back to it once you've deployed the first charm, and then you're going to be like, ooh, interesting. The setup. So you can install Jhack either from sources or there is a snap, strictly confined since a couple of weeks. And for this demo, or like for the things that I'm going to show now, I have deployed Prometheus K8s and Traffic K8s charms on a local micro-K8s cloud, but you're free to try out the same commands with your own model, and it should not make a difference. So this is the situation. I have 2 Prometheus units, 1 traffic unit, and they are related. Here I have Juju debug log running, and here I have Juju models on a watch. That's a nice introduction for the first category. The first category of Jhack tools are tools to see things. The thing is, if you're familiar a bit with the Juju model, and by model I mean the way in which Juju sees the world, Juju works by, well, the top level entity in the Juju world is a cloud to which you can bootstrap a controller, in this case a micro-K8s cloud, or a LexD cloud, or your Google cloud, or public cloud, or private cloud, or whatever. Inside the cloud, you get to add models. Models which are in K8s namespaces, or just building blocks of your ecosystem of applications. Inside each model, you get to deploy applications, and depending on their scale, each application might have a variable number of units. Another first-class citizen in the Juju world is relations. Relations are entities that exist between apps, so you can relate to applications, and either between across models or within the same model. And if it's a cross model, we call it a cross-model relation, but it doesn't really matter here. Now, what do we see when we use the built-in Juju CLI tools? What do we see about this world? We see what controllers there are. We see what models there are. We see what applications, what units, their IP. So we do have some information. It's the one. So the one I'm showing here to the right is the Juju status. So that is like the top level presentation of the world that Juju offers to us. When we are developing a charm, however, there are other parts of the world which are more difficult to inspect by using the native Juju tooling. So that's where I invested some effort into bringing that more to a visible area. What we would like to see in particular when we're developing a charm, when we're debugging it, is what events a unit is receiving, what the relation data is. We talk of data bags typically, so we want to see the raw data structure that is inside this little shared database, which is a relation. And thirdly, we would like to see the stored state, which is again like a persisted storage that is one of the only ways for a charm to maintain some state across executions. The first tool in this category is the one is Jhack tail, which is a tool that I use to follow, to tail again in real time what events are being fired on what units in my model. And that is the command that I have running up here. So you can see that I run a Jhack tail, and the last 9 events fired on traffic. So that is what this little command is showing. So it's showing that it's received some configuration storage, config changed, and then it started, Pebble ready, and then some relation events because of the ingress per unit relation that it has with Prometheus. I could make that history longer, and I would be able to inspect up until, from install. So that's probably the first event that traffic have received. And I can omit the unit name to just see all events fired on all units. The next command that I want to show is show relation. So this command is about visualizing the contents of the relation data bag, so the raw data, nicely formatted and easy for debugging purposes. I'm going to switch this back to traffic. Let's show relation. So this is the contents of the, let's print a bit better. These are the contents of the traffic Prometheus shared data bag. Pretty printed with colors. And it's just very useful when you're debugging to see things change in real time. Again, you can put this on a watch, and you can see things change as you reconfigure traffic, for example, or as you do your debugging. And finally, show stored, which is very similar to show relation, and it's for visualizing the stored state that a charm has assigned. As it turns out, actually all charms have some stored state, because also the framework itself does use some storage state. But yeah, so this is a visualization of the contents of the short state of Prometheus. So you can see that Prometheus has 3 instances of stored state. One of them is used by the Grafana dashboard provider, the requirer, the endpoint, and the other one is for ingress. And the third one is from the charm itself. So you see that 2 of the states are used by charm libs, and one of them is by the charm itself. So these are the 3 tools that I developed for introspection, and say for seeing what the low-level data inside a running charm. The second category of tools that I developed for that we developed for Jhack is a set of tools to do things. Now, hopefully better or just differently. So some of these are more experimental. This one is I like this a lot. This is a bit more than a tool. So it's a tool, but the nice thing about this tool is that it enables a new workflow. It's a tool to essentially simulate events on a live unit. So as you know, Juju decides when a unit should receive an event. Juju decides when it's time to fire an update status. Juju decides when it's time to fire a Pebble ready event, and so on. So you cannot really ask Juju, run me this event. Well, you can kind of trick the charm into thinking that a given event is being run, and that is what we're doing now. And just to show you a bit what the power of this tool is, let's also show another tool. I'm going to bring up quickly the traffic charm source code, and I'm going to use a sync command. So this is another Jhack command, which essentially watches some files, typically charm source code, for changes, and whenever there's a change, pushes it to a live unit. So what I'm going to do now is on update status, is just draw example, but suppose that you're debugging or developing a charm. You might want to do self unit status active status hello operator day, and we save it. You can see here that it's being synced, and well, you cannot see the status yet because we didn't run an update status yet. So we could wait for an update status to occur. We could even speed the rate at which update status events are occurring. But well, let's fire one. Jhack fire traffic 0 update status. So this is going to fire update status event on traffic 0. You can see that even Tail picked it up. So so far as we are concerned, that charm just ran that event, and you can see that the status changed. So it says now hello operator day, which is nice. Yeah, you can imagine that you can do this. You can do this all day and just keep altering the logic and seeing how, just different events. You can just do your regular development, but in a much faster way, because you don't have every time to rerun re-execute the sequence of Juju commands that led to this event being fired. I could even fire ingress period relation change, right? So, and then the charm will execute with that context. So long as the event handlers are idempotent, so long as they make as little assumptions as possible when it comes to their initial state, and they always lead to the same final state, this should be safe to run. But then, of course, keep in mind when using this tool that you do risk bringing things in an inconsistent state from which Juju and the charm itself cannot recover, because suppose that now I were to fire a remove event, then the charm is going to tear down a bunch of things because it thinks, hey, I'm about to be removed. The charm is about to die. So after that, the state might be inconsistent, because what I'm doing here is I'm mocking events, but Juju does not know about this, right? So this is outside of Juju's control. So yeah, just a word of caution. Let's go back to the presentation. So you can see that this enables a new workflow. Suppose you have a bug, you deploy locally, and then you write your code locally, which is great unless you're a Vim-only fan, or if you really like doing your deployment, your coding on a live unit. You can sync the code immediately to a running Juju unit, and you can replay the event over and over. You can fire it and try and reproduce the bug. If it's fixed, go on, write your tests. And so it's a much tighter loop, which, again, with the caveats that I mentioned before, cannot always be followed. In some cases, this is not going to work. But yeah, it has a lot of potential, I believe, and I do use it a lot. Like an evolution on top of this context is a more complete replay scenario. So what I would like, so this is a bit of a development, a tool still in development, so there might be bugs, disclaimer, but the idea is that you install on a live unit a recorder script, a script that essentially every time that the charm is executed is going to capture the event somehow, serialize it, dump it to disk, and every time that you want to, then you can rerun the charm in the same context. And via some smart memoization of the hook tool calls that the charm makes, so that the calls that the charm makes to the Juju backend to inspect the model data, so like relation data, for example, leadership status, and so on, By memoizing the replies to these hook tool calls, we can reproduce a charm execution even long after that state is gone. In the future, I hope to be able to use this serialized representation of a charm's, let's say, environment runtime or execution context to run the charm locally in an integration testing scenario, or actually, scenario-based testing situation. So let's show what we have. So let's do Jhack replay install traffic 0. So it's going to install the recorder on the charm. Now, if we do list traffic 0, it's going to complain that there are no events in the database yet, which is totally true because we just installed it. So let's nuke the ingress relation. That's another fun command, just because I do this a lot. And then let's relate them again. So you can see above there's a few events coming in. There's a relation departed, broken, created, joined, and so on. So there's a replay list. And now we see that there are a bunch of events that have been recorded. So these are the events that we have captured. Now, we have some more 5 minutes, so I can show you roughly what's in there. There's a lot of stuff, but the most important thing is the environment. So as you know, a charm is executed in an environment, and that is what ops wraps, right? So whenever you say ops from char code, whenever you do self.unit, how does ops know what's the name of that unit, where does that unit live, what's the address of the Juju API, and so on. That information all comes from the environment. And the second component of this recorded call is a bunch of memos, I call them. So it's essentially recording of all of the calls that the charm made to the Juju API. So for example, these are the logging calls that you would see in here in the Juju debug log. See a bunch of errors now, but it's not mine. So for example, relation IDs, all the familiar hook tools. So you see that there is more in that than just the event, right? So there's also a recording of all of the calls that the charm made to the Juju world, which means that we can now rerun that event without actually calling Juju anymore. So we're just isolating the charm's runtime from Juju temporarily. It's not forever. So we can emit things. For example, let's list it again. So we can re-emit the ingress per unit relation changed as it just occurred. So you should see if the tail works, or maybe there is a problem here. Yeah, I'm not sure sometimes why it does not log the charm execution, but so yeah, we're not able to see it in the tail. But what's happened here is we have just replayed this event. So we have a serialized representation in a database of how this execution interacted with the Juju world. So for example, when the charm called, "Am I the leader?" what did Juju reply, true or false? So we can re-execute the charm in the same context and with the promise that the same path will be taken in the charm code, which is great for debugging. yeah, for developing. So you can just run the same event over and over, and also be guaranteed that Juju will give you exactly the same, expose the same data to the charm, which means that you can isolate a lot more the context in which you are running a charm in a real deployed situation. So the workflow that this enables is, well, like, I think one of the main goals of this tool is to enable a way stricter reproducibility of a charm execution. So you have your deployed live charm, it runs, you grab all of the information that you need, and then you get to replay that run, that execution remotely or locally, however many times you want. And I think that's a very powerful use case for regression testing, and yeah, in general for developing a charm and just debugging its logic in a more controlled manner. So closing, what are the next steps that I would recommend? Well, if you're not already, get charming. Go to charmhub.io, see what's there. Second point is, of course, get Jhacking. Install it from sources, get it from Snap. Check out the other Jhacks. I've briefly showed Nuke, briefly showed Replay. There's Provision. There's a number of other little things in there. The thing is, the charming ecosystem is growing. There are people like me developing tooling out there, so it's a great time to be around. And since most of these tools are still at their infancy, it's also a great chance for interested people and parties to contribute and influence the direction that they're taking. Third and last, don't forget to have fun. And with that, I close and give the word back to David and to the next speakers for today.